Alright, welcome back to Mr. PS with Algebra. This is U2T3, Topic 3, Lesson 6. This time we're going to be doing elimination method to solve a system of equations. Starting us off with a simple find the pattern, 3, 6, 9, 12, 15, 18. That's simply adding 3. I know that because it's increasing. This one happens to be 3, 6, 12, 24, so that's times 2, times 2, times 2. This would be 48, and this would be 96. Those numbers are increasing very rapidly, so therefore I knew it was a geometric pattern, and it's times 2. And this one's going to be 24, 20, 16, 12, 8, and then 4. And that one's decreasing, so that's an arithmetic pattern because it's decreasing by 4. It's adding negative 4, so it's adding, which makes it arithmetic. All right, so elimination method, and I'm going to skip by that. That is actually not relevant to this. Elimination method is another way of solving a system of equations. There's 3 ways. You've probably already watched the the substitution method, and there's also you can graph the 2 equations, see where they intersect, or you can use this other method, which is called the elimination method. And the reason why it's called elimination method is because simply you are going to eliminate one of the variables. You're going to do whatever it takes, either adding or subtracting the 2 equations to eliminate one of the variables. Well, look at the coefficients. The coefficients are the same. That's going to make this method very, very easy to use because now all I got to do is, since these are the same, it's already set up perfectly, I'm going to add the top line and the bottom line. Now, why am I going to add? Because negative 4 plus 4 is 0. Those are what we call additive inverses of each other. So additive meaning if you add them together, you get 0. So this plus this makes nothing. Negative 2 plus 8 makes 6y's. And negative 12 plus negative 24 makes negative 36. Okay, pen, there we go. That works a little better. Divide both sides by 6, and that means y has to be negative 6. Now, once you found y, all you got to do is plug it back in and solve for x. Plug it back into one of the equations. It really doesn't matter which one. I'm going to use the top one, negative 4x minus 2 times negative 6. Equals negative 12. All right, negative 4x, bring that down, multiply, negative 2 times negative 6 is positive 12, equals negative 12, so subtract 12 from both sides, negative 4x equals negative 24. Divide both sides by negative 4 means x is 6. So the answer is 6, negative 6. That is the one place that these 2 equations will intersect each other. All right, so I'm going to change colors here. Going down to number 3, elimination method is also perfect for this. By the way, these questions were made for elimination method because they've got coefficients that are the same. So this time I'm not going to eliminate the x, I'm going to eliminate the y. You can eliminate either variable. As long as the coefficients are the same, you can eliminate it. In this case, it's going to be additive inverses again because these are opposites of each other. X plus 2x makes 3x. This one, if you add these, you get nothing. And 19 plus 11 makes 30. And then divide both sides by 3, and you've got 10. Now, I would like to spend a little bit more time on this video going through the process. So what I'm going to do is I'm going to stop finding the other variable because I think I've kind of, if you watch the other video, you probably already know how to do that anyway. So if you take x equals 10, plug it back in. So maybe I'll do it one more time. So if I plug it into the top equation, that's 10 minus y equals 11. Subtract 10 from both sides means negative y is 1. And multiply both sides or divide both sides by negative 1. Doesn't matter because they'll give you the same result. Means the answer is negative 1. So 10, negative 1 is the solution. Okay, so I'd rather spend some time just talking about how to find the first variable. The second one, you can take it, plug it back in into either equation and solve for it. You've seen some examples. So when I look at number 5, I notice that the coefficients are the same, but they also this time have the same sign in front. They're both negative. And any number minus itself is 0. Now, these is what we call additive inverses because if you add them, they're inverses of each other, so if you add them, they're going to equal 0. But when you have 2 numbers that are exactly the same, any number, no matter what it is, doesn't matter if it's, I don't want to get into irrational numbers, but if it's a rational number, then if you subtract it from itself, it will always equal 0. It doesn't matter if it's a fraction, a decimal, a negative number, a positive number, it doesn't matter. Negative 2 minus negative 4 is positive 2x. Leave change, change. Use a calculator if you're not quite sure about doing integers. That because negative 2 plus 4 makes 2. This makes nothing. That was the whole point. Negative 25 minus negative 23 makes negative 2, which means x has to be negative 1 once you divide by 2 on both sides. All right, so I'm going to skip over here, and I'm going to notice that once again, we've got variables with the same coefficient. So I'll do the same thing, which is subtract. This minus this is 11x, and this minus this is negative 11. Divide both sides by 11 means once again you get negative 1. All right, so let's skip over here. It looks like these coefficients are the same. I can't get rid of y, but I can get rid of x. They are opposites of each other, which means they're additive inverses, so I'm going to add. This plus this makes nothing. This plus this makes 9y, and this plus this makes negative 9. Look at that. Divide both sides by 9, and once again, we're getting a variable of negative 1. I am noticing a weird-looking pattern here. I know this was the second one and not the first variable I solved for, but negative 1, negative 1, negative 1, and this one had a negative 1 even though I had to solve for it again. Very weird how that's working out like that. When I look at number 8, I see two variables that are exactly the same, so that tells me I'm going to subtract. 7 minus 8x makes negative 1x. These eliminate, and 24 minus 30 makes negative 6. Divide both sides by negative 1. And nope, we didn't get negative 1 this time. It looks like we got positive 6. Plug that back in. I'm just going to try to do that in my head because I want to see if it's negative 1. 7 times 6 is 42. 24 minus 42. What is that going to be? 24 minus 42. I should have just gone the other way around. Sorry, I don't know why I'm doing it. So that's what, negative 18? Nope, that's going to be 9. Okay, sorry. I went off on a little 10-second tangent there. I just had to see if it was another negative 1. That would have been weird. Okay, so now we got some new questions here. And these are a little bit different. What you're going to notice about 9, 10, 11, and 12 is that none of the variables, either x or y, are going to have the same coefficients. So in this case, you're going to have to multiply. I want to make them the same. So I scan them, and I'm kind of looking at, well, look at the x's, look at the y's. What could I do to make them the same? Well, it'll be easy if I multiply the top line by 2. If I make this times 2, that's going to turn that into 10x. That's going to turn this into 2y. And this 9 is going to turn into 18 because multiplication... 18, not 19. The multiplication property of equality states you have to do to everything. You have to multiply it on both sides if it's going to stay the same. So then I can cross this off and then I can do the same. I can be subtraction. This minus this makes nothing. 2 minus negative 7 makes 9y. And 18 minus negative 18 is 36, which means y has to be 4. All right, so let's look at another question. So the first thing I'm going to do is look for what's going to be the easiest way to solve this. I can multiply the bottom line by 4, and that would make the x's the same. Or I can multiply the bottom line by 3 and make the y's additive inverses. So I think I'm going to do that. I'm going to multiply bottom line times 3, which makes this 3x, and makes this 9y, and it makes this negative 18. And now I can cross this off, and I've got additive inverses of each other. Okay, so I'll let you take over from there, and I'm going to show you just 11 and 12, and then we'll move on to the homework. So I look at this problem, and I notice that, well, it's going to be pretty hard to make these both the same. I could make both the x's 14 by multiplying the top line by 2 and the bottom line by 7. You can do that. Although that would be more work because then I have to multiply two things. So I'm going to simply multiply the top line by 3 because that one step is going to make the y's the same. So this becomes negative 21x, this becomes 3y, and this becomes, let's see, 19 times 27, negative 57. Then I can cross this off and I can subtract because these coefficients are the same and they have the same sign in front of them, so anything minus itself is 0. And last but not least, let's take a look at number 11. Looks like 7 and 5 are going to be pretty hard because you can't multiply 5 by anything to make 7, at least not a whole number. So that's going to be pretty hard to make the same. So I'm going to go to the x's. What can I do to -3 to make it -9? And that would be multiplying it by 3. This times 3 is -9x. Times 3 makes 21y. And times 3 to 16 makes -48. Then I would subtract them because these two are the same. And that will be it. Alright, so let's take a look at that homework. The homework says, solve the system of equations using substitution. Justify graphically. Tickets to a show cost $10 in advance and $15 at the door. If 120 tickets are sold for a total of $1,390, how many tickets were bought in advance? I feel like this is the same question I might have had on a prior video. If it is, then I'll just have to make another video of the new one. But I'm going to go ahead and solve this question. So we've got $10 in advance. So let's make X the advance tickets plus $15 at the door. That will be the Y tickets. And that has to make, if 120 tickets are sold for okay, so that makes exactly $1,390. Now the other one is if you sell tickets prior plus at the door, and that was 120. Alright, so in this case, I probably would use elimination method. I would multiply the bottom line by 10. This becomes 10x, this becomes 10y, and this becomes 1,200. Cross this out, subtract, 5y equals 190. Divide both sides by 5, and that tells me, let's see, 3 times 5, 15, 4, 38. So y must be 38. So it looks like we sold 38 tickets at the door. Well, if it was 120 tickets minus the 38 tickets, that's going to give us 11, 10, 9, 8, 82 tickets. So it looks like X is 82 tickets, and Y 38 tickets at the door. Alright, please give it a like if I helped you learn something, and subscribe if you haven't done so already. Thanks again for watching. Have a